We're looking at homework from section 4.2 today. It's question number 10. Let's go ahead and read the question. 23% of college students say they use credit cards because of the rewards program. You randomly select 10 college students and ask them each to name the reason he or she uses credit cards. Find the probability that the number of college students who say they use credit cards because of the rewards program is A, exactly 2, B, more than 2, and C, between 2 and 5 inclusive. If convenient, use technology to find the probabilities. This is a binomial experiment because either the student says they use the reward program or they don't. So there's two choices here. That makes it binomial. Once we know it's binomial, we need to know the values of n and p. N is equal to the number of college students that we selected, which was 10. And p is the probability of finding one that uses the rewards program, which is 0.23. So to find this probability, we're going to turn to the probability formula, which is p of x equals ncx, p to the x, q to the n minus x, where n is the size of the sample, p is the probability of success, q is the probability of failure, and x is the number of successes that you're looking for. So here we're looking for 2 successes, and we also need to know that q value. We know that q is 1 minus p, so q is 0.77. So taking all those things into consideration, we start plugging in numbers. We're looking for the probability of 2 equals ncx, that's going to be 10c2. P to the x is 0.23 to the 2, and q to the n minus x is 0.77 to the 10 minus 2. We simplify that power, so it's going to be 0.77 to the 8th now. 10c2 is 45, and when we multiply this all out, we get 0.2941670242. Rounded to the nearest thousandth is 0.294. So if we were just using the formula, that's how it would look. We can also do this by using the calculator. What we would do then is we would do binom PDF 10, 0.23, 2. So when you're entering things into the binomial formula, you always start with the n, then the p value, then the x value. You don't need to enter the q because the q is something that the calculator knows how to compute. Once you know p, q is 1 minus p, so it's got that all built in. So you just have to enter the values of n, p, and x, and then when you hit enter, you still get that same answer, which is 0.294. Let's take a look at part B. This time we're looking for the probability that x is greater than 2. So we really want to use the calculator this time. And the reason that we want to do that is because for this example where n is 10, x greater than 2 would mean we would have to plug in the value of 3 and the value of 4 and 5 and 6 and 7, 8, 9, and 10 and add those probabilities all together. Well, that's 8 different calculations that we would have to perform. It's just like doing part A 8 separate times. So we really want to turn to technology on this one. If we're doing this probability that x is greater than 2, again, like I said, we're adding these 8 probabilities together. And the TI-8384 graphing calculator can do this for us. There's a nice built-in function that's going to help us out. So that built-in function is called the Binomial Cdf Formula. So now this Binomial Cdf Formula that I just mentioned can be used to add binomial probabilities, always starting when x is 0 and continuing to an x value that you specify. So it's going to start by plugging in 0, and then it plugs in 1, and then it plugs in 2, and then it keeps plugging in numbers one by one until the value that you tell it to stop at. Now, this sum that we're doing here doesn't start at 0, right? We said we're doing the probability of 3 and 4 and 5 and 6 all the way up to 10 added together. So that means we're going to have to do a subtraction. It's actually a complement to what we're looking at. Let's think about it really closely. The sum we want doesn't include x values between 0 and 2 because the probability of 0, the probability of 1, and the probability of 2 are not greater than 2. So those are the three that we'll have to eliminate. How do we do that? Well, what we're going to do is we're going to do that binomial CDF of 10, 0.23, 2, which is adding up the probabilities from 0 to 2, but then we're going to subtract that from 1. And when we do that, we end up with 0.413-717-2765. Rounded to the nearest thousandth is 0.414. So think about why we did it that way. Again, if we were looking just at all the probabilities, that would be probability of 0 and 1 and 2 all the way up to 10. And that would always add up to 1, right? Because those are all of the different possible things that could happen. We don't want a few of those, right? We don't want the 0, the 1, and the 2. So we use the binomial CDF to add up the 0, 1, and 2, and then we take it away from 1. It's easier to do that than it is to calculate 8 separate probabilities. Let's go ahead and look at part C. This time, we're looking for the probability that the x falls between 2 and 5. So again, if we were doing that part A process where we just did the formula and plugged in numbers in the formula, then we would have to do 4 separate calculations within that formula. We'd have to do the probability of 2 and 3 and 4 and 5 and add those all together. This time, we're going to have to do 2 binomial CDF formulas. Why 2? Well, again, we don't have a sum that includes 0, right? This sum starts at 2, not at 0. So what values aren't included? Well, we're not including the values that are less than 2, so the probability of 0 and the probability of 1. We're also not including the values that are more than 5. So what we're going to do here is we're going to take 2 separate binomial CDFs and subtract them. So we're going to do the binomial CDF of 10, 0.23, 5. That's going to add up all the probabilities starting at 0, ending at 5. So that's probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. Then we're going to subtract away binomial CDF of 10, 0.23, 1. That gives you the probability of 0 and 1. So if we take those away from that first sum, we'll be left with the 2, 3, 4, 5, which is what we want. And so if we plug that into our calculator, we get 0.6948675641, rounded to the nearest thousandth is 0.695. And that's your answer.